Summer of 2018. The coast of Florida, the town of Cedar Key. Local oystermen take their boats out onto the flats. The season is closed and no one is allowed to harvest right now. But these men were hired on purpose, and the job they were given is a strange one. Pull the live oysters off a strip of bottom that is about to be buried under rock. They work by hand, at low tide, and over a few weeks, they lift about 130 cubic yards of live oysters. Hundreds of thousands of animals loaded into boats and hauled away. Then the barges come in and dump 17,000 cubic yards of rock onto the emptied bottom. More than 5 Olympic swimming pools. Not fine gravel, but blocks running from the size of a grapefruit to the size of a washing machine. From the outside, it looks like the destruction of what little was still left here. And then the oysters are brought back and poured out on top of the rock. Before the barges arrived, a square yard of this bottom held only about 8 oysters. 5 winters later, they counted 182, more than 20 times as many. And before all this, Florida had tried to save its oyster reefs 6 times, had spent more than $14 million, and had gotten nowhere. And still people kept coming back, because this was never really about the oysters themselves. A whole living world rests on them, and that world was what people were trying to save. To understand what that world is, we first have to look at the place itself. Suwannee Sound lies along a barely developed stretch of the Florida coast, where the fresh water of the Suwannee River mixes with the salt water coming in from the Gulf. Long ridges run along the shore, hidden underwater for most of the day. When the sea pulls back, they rise into the open, and it becomes clear that these are not rocks at all, but oysters. Millions of oysters grown on top of one another in layers. One of these ridges is called Lone Cabbage, and it runs about 3 miles, not as one solid wall, but as a string of separate reefs. It is at least 2,000 years old as the Roman Empire. It has lasted this long because a living oyster reef builds itself. An oyster attaches to a hard surface once and stays there for good, and when it dies, its shell becomes the footing for the next one. The shells work like bricks, and the living oysters on top of them work like the mortar that holds the courses together. What comes out of it is something like a wall, and this wall grows back faster than the sea can break it down. A storm tears chunks off the ridge, and in that same time, it builds itself back higher than before. For 2,000 years, it rose on its own, without a single builder, and all that time it was working for the whole bay at once. First of all, as a home. Flat sand is an empty field, no crevices, no hard footing. A reef rises above that field like an entire building with ledges, hollows, shade, and apartments of every size. Algae and small creatures grow on the rock. Snails and worms feed on them. Crabs and shrimp sit between the stones. Young fish move through, and larger fish come in after the young ones. And this house runs in 2 modes. While the reef is underwater, its crevices serve as shelters. When the water goes out, that same reef turns into a dry island of rock in the middle of the bay, where birds rest and hunt. One and the same ridge feeds the life below the water and the life above it, switching between them every few hours. Next, as a filter, every adult oyster strains water through its gills, pulling out silt and tiny algae. And in a single day, as much as 50 gallons can pass through one of them. And there are millions of them on the ridge, working without a break and without a single motor. They take the murk out of the water and let more light down to the bottom, and the light brings the seagrass back, which is another home, this time for other species. And finally, as a breakwater, the ridge stands in the path of the surf and takes the hit. The wave reaches the shore already weakened, and the sand stays where it is. Where reefs break down, the shoreline starts breaking down right behind them. That is why biologists and state agencies kept going back to oyster reefs, even after 6 failures in a row. Oysters here are valued as food too, of course, and the harvest fed Cedar Key for generations. But the millions were not being spent for the sake of the catch. They were spent for what this reef does to the bay itself. As long as the ridge stands, the bay has a home, clean water, and protection from the sea. Take the ridge away, and none of that is left. And that is exactly what happened here. The ridge took 2,000 years to build. It came apart in 30 years within a single lifetime. It started with the water. An oyster needs neither seawater nor river water, but a mix of the two, and that mix was what the Suwannee River made in the bay. But it was not even about the water itself. The river flow held back the enemies that came in from the sea. Predatory snails and diseases handle salt water easily, but they do much worse where the water is less salty. The river worked for the reef like a defensive moat, and as long as the moat is full, the enemies keep their distance. From the 80s on, that moat began to dry up. Droughts grew longer. People upstream were pulling more and more fresh water out of the river, and where the river pulled back, the sea moved in to take its place. The salt levels rose, and the enemies moved in with them. But the death of the oysters themselves was not the worst part. The mortar that held the courses together disappeared along with them. The bricks stayed where they were, but there was nothing binding them anymore. A wall like that holds only until the first big wave. The storms finished the job. They dragged the empty shells across the bottom and ground them into chips, and there was no one left to lay a new course. For 2,000 years, the wall had grown back faster than it was broken. Now it finally started losing to the sea. The ridge settled, and what was left of it was buried in sand. In the early 90s, Lone Cabbage was made up of 38 separate reefs. By 2010, only 13 were left. It ended the same way it does when a tall building is torn down. What stays behind is a flat lot. No crevices, no filter, no breakwater. It was not one species that vanished. Everything the ridge had been holding up went with it. And for the oysters themselves, this was a death sentence. A larva has to find a hard surface and glue itself to it, and it does not have much time. If it fails to find one, it dies. Now they were landing on sand the way seeds land on concrete, without a single chance of taking hold. And here is where it got worse. The situation stayed hopeless, even in the years when the river brought plenty of water again. There was less salt, there were fewer enemies, and things were getting easier for oysters again. But that did not make the bottom come back. What killed the reef and what kept it from returning were two different things. The moat could be filled again, but by then the walls had already crumbled, and so there was only one way left. Simply pouring oysters onto the old sand would have been pointless. With nothing to hold on to, they would have been scattered across the bottom by the first storm. What had to be brought back was not the oysters, but the thing the bay had lost, the hard ground underneath them, rock. Still, before anyone hauled it in by the thousands of tons, there was one question to answer. No one had seen larvae in the bay for 30 years. If none of them were left, there would be nobody to settle on the rock. So they started small. In 2013, clean limestone was laid down on a few small plots, rock that did not have a single oyster attached to it. A year and a half later, it was covered in young oysters, while the bare sand around it stayed bare sand. The larvae had never gone anywhere. What had disappeared was the place where they could live through their first months, so the rock could be hauled in. And 4 years later, the real work began. The money came out of the settlements over the oil spill in the Gulf of Mexico. 3 researchers from the University of Florida led the project, and dozens of people worked out on the water, including oystermen from Cedar Key. The goal they set was not about the harvest, to give the bay back not a head count of shellfish, but the shape of the bottom that everything else rests on. The first thing to decide was how high to raise that bottom. Normally, a number like that comes out of a calculation or gets trimmed to fit a budget, and that is how it went in all 6 earlier attempts. Here, for the first time, they did it differently. They went to the neighbors. A couple of miles from Lone Cabbage stood living oyster ridges that had survived since ancient times, and they had known the right answer all along. They had lasted precisely because they stood at the right height. The scientists waited for low water, walked out on them, and simply took the measurement. About 16 inches above the bottom, roughly the height of a chair seat. Everything else was taken from that same neighboring reef. The shape and the mix of rock in every size, from small broken pieces to boulders. A neat, even layer was not what was wanted. because real life begins in the gaps between the stones. The outline was rebuilt from old nautical charts from the days when the ridge was still whole and the ancient channels that carried water were left open. It was as if nature had handed over a finished blueprint and the engineers only turned it into tons of rock. In the summer of 2018, the barges arrived. 26 separate rock pads were laid along the historic outline. Not one solid bank, but a line of islands with water running freely between them, the way it always had. Loose shell was spread on top by hand so that young oysters would have small crevices to settle into. And when everything was ready, the oysters were brought back to the reef, the same ones that had been taken off it at the start of the summer. The first young oysters showed up on the rock within a few months, but that still did not really prove anything. The adults had been carried in by people, and through the first winter, those were mostly what turned up. Only the years ahead would show whether the ridge had truly come back to life. They counted for 5 winters in a row, by hand, at low water, both on the new reef and on the neighboring ridges, where no rock and no oysters had been brought in. That was the test. If the whole bay were recovering on its own, the growth would show up everywhere. On the neighboring ridges, the numbers stayed flat or fell. On the rock pads, they climbed every year for 5 years running, and no transplant could explain that. The oysters people carried in could have caused a spike in the first winter, but not 5 years in a row. The ridge was already raising young of its own. A square yard of reef held only about 8 oysters before the restoration. 5 years later, there were 182. And there was one more number that took a while to notice. Across all 5 winters, not one spot was found on the new reef where oysters were missing entirely. Not one. On the neighboring ridges, the dead patches stayed there the whole time. You can see it in the photographs taken during the counts. A man with a measuring tape stands knee-deep in water on bare-packed sand, and 1 step away from him, the ridge rises, so thickly covered in oysters that the rock underneath is no longer visible. On the rock, there are oysters. On the sand right next to it, not one. Within 3 years, the oysters here had grown to the same size as the ones on the surviving ridges nearby, and the ridge had started building itself again. And a year after that, the same oystermen who had once cleared this bottom for the rock came back out here to harvest. Not because there was suddenly a catch here, but because the ridge was working again the way it had worked here for 2,000 years. But the most interesting part was not happening to the oysters. It was noticed back on those same small plots a few years before the barges. The first ones to move onto the rock were blue crabs. They started turning up between the blocks far more often than on the sand nearby, and it is easy to see why. The gaps, running from the width of a finger to the width of a hand, turned out to be exactly the size an adult crab or a small fish needs. By now, the rock was more than a footing for oysters. It was a shelter for everyone else. And then they spotted a detail that no one had thought much of at first. Even on one single rock, life had spread out unevenly. Young oysters did well up on top and down at the very base, where the rock met the sand. But across the middle, there was an almost empty band. The scientists named it the death band. That height is exactly where crabs and fish can get at the young oysters most easily without exposing themselves to their own predators, and that turned out to matter more than any count. A year and a half earlier, dead limestone had been lying here. Now, ordinary reef life was running on it, safe up top, dangerous in the middle, and the same race every single day. Who gets to hide and who gets to eat? The birds came too. At high tide, when the flats went under, the rock pads stayed dry, and cormorants and bald eagles started landing on those little islands because height is what they need. And the sandy flats next door stayed with the ones that needed sand. That is the main thing the reef did here. Where there had been one habitat, now there were 2. Restoration does not make things better for everyone at once. It brings variety back. Where there used to be one flat stretch of sand, several different worlds now sit side by side. And that is what the whole thing was for. Not so much for the oysters themselves as for the bay that rests on them with its floors, its shelters, its hunting, and its dry islands above the water. The oyster turned out to be the key link here. As long as it holds, everything else holds with it. There was still one question left, though, and the fate of every future project depended on it. What exactly was it that worked? After all, the rock was not the only thing that changed over those years. On part of the reef, harvesting had been banned outright, and in those years, the river was bringing down more fresh water than it does in a drought. Maybe the oysters came back because of that, and the rock had nothing to do with it. 14 years of observations made it possible to test both hunches against the numbers. Neither one held up. Where harvesting was banned, there were no more oysters than before. In the high water years, the same. And on the rock, there were more than 20 times as many. The result was also compared with the 6 earlier attempts to save Florida's reefs. There, loose shell and small gravel had been spread in a thin layer, and young oysters would show up now and then. But a couple of years later, they were gone again. The difference is simple. Here, what was brought back was not a surface for the larvae, but the old height and the full body of a whole reef, footing that holds. And it is still holding. Storms have crossed the bay more than once, and the pads have settled by about the width of a hand, but the height of the ridge is still the same as on the living ridges nearby, and the rock has not gone anywhere. Everything that has been brought back at Lone Cabbage adds up to 3 or 4% of what this coast lost. That sounds like very little, but the point is not the percentage. The point is that after 7 attempts, it is finally clear how this is done, and it does not cost much. Oyster reefs are one of the most damaged marine ecosystems on the planet, and there are thousands of bays around the world where flat sand now lies in place of a living ridge. Such a bay has not simply lost its shellfish. Gone is the filter. Gone is the shelter for crabs and shrimp and young fish. And gone is the breakwater that used to stand in front of a shoreline that now has to meet high water on its own. And now it is clear what to do about bays like that. And it is not really about 16 inches. In the past, projects like this started from an answer people came up with themselves, whatever the calculation showed and whatever the budget allowed. Here, for the first time, the question was put not to a sheet of paper, but to a living reef next door. And in every bay, the answer will be its own. A different wave, a different current, a different height. There is no universal number, and looking for one is pointless. It has to be asked all over again, every single time. That, and not the technique for laying rock, is what is being carried away from Lone Cabbage today, first into neighboring bays in Florida, and after that farther out. All those 30 years, the larvae kept arriving here with every tide. There was simply nowhere for them to take hold. And when people finally stopped guessing, the answer turned out to be a surprisingly simple one. They waited for low water, walked out to a living reef that had been holding on here since ancient times, and took its measurement. 16 inches. That was exactly how much footing the bay had been missing. People did not build an ecosystem because building one is impossible. They raised the bottom and gave the bay back its ability to build itself. And now they know how to do the same thing in thousands of other bays where bare sand is still lying on the bottom.